Hello and welcome to the Telegraph Studios, where I'm delighted to be joined by Professor Anthony Coates from St George's University in London. Professor, we hear a lot about antibiotics in different contexts, their failure in medicine, their infections in hospitals, overuse in agriculture. Can you give us a brief history of antibiotics?
Yes. It all started a very long time ago with some microorganisms, very, very small organisms called bacteria. And these appeared on the planet at least 3 billion years ago, and they fight each other. And they fight each other using arrows, which are poisons actually, which we call antibiotics. And they defend themselves against these arrows with shields. Shields rather like the old metal shields used in gladiatorial fights. This has been a battle which has been going on for a very long time. And in 1928, Alexander Fleming discovered penicillin, which was the first arrow which was used, antibiotic which was used widely in the 1940s for human disease, human bacterial disease. And this was followed by a burst of activity in which 20 new classes and about 200 antibiotics in total were developed between 1940 and the late 1970s. And since then, unfortunately, humans have produced many fewer antibiotics and virtually no new classes of antibiotics.
So you talked about the resistance of bacteria there, but why have we failed to keep up in this race?
Well, bacteria make new shields on a daily basis. This is called mutation. They make bigger shields, they make wider ones, they make thicker ones, they use different materials to make these shields to defend themselves against antibiotics. And we haven't produced new antibiotics properly, certainly not new classes, for 40 years. Well, bacteria have been doing this every day. You can imagine that they have many more resistance mechanisms than we have antibiotics. And so some antibiotics in some countries are now basically useless. They're not active against many of the bacteria which are affecting humans.
This it's caused me very hard to keep up then, obviously. What effect does that have on healthcare for us in this country?
Well, it has a very marked effect now, but it's going to have a much bigger effect by, say, 2050. Now, the O'Neill report, which was commissioned by Prime Minister Cameron, has shown us in its first few reports that the penalty for the human race of not tackling antimicrobial resistance is very large. For example, the report has suggested that the overall cost to the human race by 2050 will be approximately $100 trillion. And this equates to about 2% of GDP annually from all countries in the world. And the numbers of deaths would go up from about 700,000 a year now to about 10 million a year by 2050.
So there are obviously lots of pressure to find solutions and find them quite fast. What are the options at the moment?
Well, the options that have been outlined in the O'Neill report is, first of all, that this is a global problem. And the 10 Commandments are what I call his recommendations. And these start with something very simple, which is washing the hands. We need to do that in hospitals better. Actually, the general population needs to do it better. Secondly, there needs to be a global public relations program which outlines this issue, rather like the smoking program. You know, this is what we need to do. Thirdly, there needs to be better surveillance, in other words, more laboratories around the world to actually count the numbers of infections and the numbers of bugs that we've got. Fourthly, there need to be better diagnostics. Fifthly, there need to be more use of combinations, particularly antibiotic resistance breakers, which I'll come to next. Then there is the issue of antibiotic research. Clearly there needs to be more antibiotic research. and the O'Neill report has suggested a new fund called the Innovation Fund, which can be used for this. Then there need to be clearly more antibiotics. You need to go down to the bottom of the sea, find new antibiotics there perhaps and other places. And this needs to be funded in some way with some kind of a reward system or development fund for perhaps big pharmaceutical companies as a reward for developing these, or small companies. Finally, the last two are agriculture. We use far too many antibiotics in agriculture. And lastly, vaccines. We need new vaccines.
That's a long and demanding list. Is it a priority, or do they all need to be done at the same time?
Well, I think we need to appreciate how long it's going to take to, for example, make new antibiotics. To make a new antibiotic will take between 10 to 20 years. However, if you use an antibiotic resistance breaker, which Health B Therapeutics is doing, that's a faster process, probably between 5 to 10 years. And the reason is that if you think of an antibiotic rather like a heavy lifting device, so penicillin is like a heavy lifting device with hydraulics and so on. The antibiotic resistance breaker is the handle which, when you pump it up and down, it makes the heavy lifting device lift, say, a car or some other heavy object upwards. And it's much easier to make a new handle than it is, and much quicker than it is to make the entire hydraulic press. So I think the antibiotic resistance breakers are a quicker way to actually address this problem, because you're reusing old antibiotics, basically.
So basically you're saying that when it comes to the antibiotics, antibiotic resistance breaker, you think the antibiotic resistance breaker is where a lot of investment should go?
I do. Because I think in the shorter term it's going to be easier and faster and less risk to make antibiotic resistance breakers which rejuvenate our existing drugs. Furthermore, I think in 50 years' time, when resistance has emerged to all of these antibiotic resistance breakers, we'll be able to do the whole thing again, make another set of resistance breakers, and again perhaps in maybe 150 years' time we'll be able to do it again. And thus we will be able to reuse our old antibiotics repeatedly over the coming decades.
So you've talked about the future there. Are you optimistic about it?
I'm very optimistic about it, actually. There is an antibiotic boom in the United States, particularly on the East Coast. Very important people, the President of the United States, Prime Minister Cameron, the head of the World Health Organization, have all brought our attention to this very important problem. And Health B Therapeutics, which is making antibiotic resistance breakers, is itself expanding. We have a partner in the East, in India, and we also are setting up a subsidiary on the East Coast of the United States.
Professor Coates, it's been fascinating listening to you talk. Thank you very much.
Thank you.